Welcome to our deep dive into the prehistoric creatures of the Eurasian steppe
Ah,
during the Pleistocene Epoch.
yeah,
We're going to journey back in time to this incredible landscape, teeming with fascinating animals.
right.
Get ready to uncover how these creatures adapted and survived
Yeah.
in a world that was both familiar and utterly different from our own.
Yeah, it's a journey that challenges some of our assumptions about
Yeah.
iconic Ice Age animals
Okay.
and reveals some surprising adaptations that allowed these creatures to thrive.
The Eurasian steppe, unlike Europe, wasn't covered in vast glaciers,
Right.
but that doesn't mean things were static.
You're right. There were still cyclical temperature changes
Ah.
that had a huge impact on the ecosystem.
Yeah.
Think of it like a dynamic mosaic of habitats,
Right.
constantly shifting and reshaping the environment.
Our sources paint a vivid picture of this world,
Mhm.
focusing on a specific location, the Zhoukoudian site in China.
Okay.
The site, famous for Peking man fossils, offers a glimpse into the unique blend of forest, grassland, and wetland habitats that characterize this region.
Zhoukoudian is a treasure trove of information,
Yeah.
allowing us to reconstruct the lives of these animals in detail,
Okay.
from their physical adaptations to their interactions with each other.
One of the first surprises for me was the presence of water buffalo
Hmm.
in prehistoric northern China.
Really?
We usually associate them with warmer climates,
Yeah.
so finding them in this environment was unexpected.
It's a great example of how species can adapt to different environments.
Okay.
The water buffalo found in Zhoukoudian weren't exactly like the ones we see today.
Yeah.
They were a species with shorter legs,
Oh, okay.
like Bubulus wansingi,
Right.
which was an adaptation perfectly suited for colder climates.
So shorter legs are actually an advantage in the colder temperatures of the steppe.
Yeah.
How does that work?
Think about surface area and heat loss.
Okay.
Shorter legs mean less exposure to the cold,
Uh-huh.
helping these water buffalo conserve body heat.
Right.
It's fascinating how evolution favors traits that enhance survival,
Yeah.
even in seemingly small ways.
It's a reminder that we shouldn't underestimate the power of adaptation,
Yeah.
even in creatures we think we know well.
Mm-hmm.
These short-legged water buffalo lived alongside other cold-adapted animals like horses and woolly rhinoceroses,
Right.
painting a picture of a truly unique ecosystem.
And this brings us to another fascinating creature,
Okay.
the hipparion, a three-toed horse.
Yeah.
Now, it's tempting to think of three-toed horses as simply being outcompeted
Right.
by our modern single-toed horses.
It's easy to fall into the trap of thinking evolution is always a linear progression
That's right.
towards something better.
The hipparion had its own set of advantages
Yeah.
that made it successful for millions of years.
Okay.
Late hipparion species,
Uh-huh.
like hipparion longipes,
Okay.
had teeth perfectly adapted for grinding the tough grasses of the steppe.
Right.
And those extra toes,
Yeah.
they probably provided extra stability on uneven terrain.
So it wasn't a case of one being superior to the other.
No,
They each had their own evolutionary niche.
exactly.
Yeah.
It challenges the idea that extinction is always a simple case of survival of the fittest.
Right.
Sometimes it's just about how well a creature's traits match its environment,
Right.
and that can change over time.
We've got these horses and buffalo grazing peacefully on the steppe,
Mhm.
but no ecosystem is complete without some drama.
Yeah.
Let's talk about the predators that roamed this prehistoric world.
The Eurasian steppe had its fair share of fearsome predators,
Yep.
each playing a crucial role in maintaining the ecological balance.
One predator I found particularly surprising
Okay.
was the giant cheetah, Cyninix pardinensis,
Right.
a cheetah in China.
Yeah.
It's not exactly where we'd expect to find them today.
It's a reminder that the distribution of species
Right.
can change dramatically over time.
Wow.
While it resembled modern cheetahs,
Yeah.
the giant cheetah was likely more robust,
Okay.
capable of tackling larger prey.
So a cheetah with even more power and speed?
Yeah.
That's a pretty formidable predator.
Uh-huh.
But who was the top predator in this environment?
You might be surprised to learn that the apex predator wasn't a cat at all,
Oh,
but a hyena,
a hyena.
the Pachycracuta brevirostris.
Seriously?
Yes.
Wow.
This was no ordinary hyena.
Okay.
Imagine a hyena larger than a lion or tiger
Right.
with incredibly powerful bone-crushing jaws.
That changes my whole perspective on hyenas. I guess their reputation as scavengers doesn't quite capture their past glory.
We often underestimate these fascinating creatures.
Okay.
The abundance of Pachacracuta fossils in Zucudian, some even with bite marks on Peking man skulls,
Wow.
speaks volumes about their dominance.
That paints a rather unsettling picture of life for our early ancestors.
Yeah.
They were sharing the landscape with some truly formidable predators. Speaking of predators, another group comes to mind, saber-toothed cats.
Okay.
Were they a major force on the Eurasian steppe?
Interestingly, saber-toothed cats were experiencing a decline in diversity in Eurasia during the Pleistocene, unlike in the Americas, where they continued to flourish.
Yeah.
This highlights the complex interplay of factors that can influence a species' success.
So different predator dynamics were playing out across the globe.
Yeah.
We've got these powerful hyenas, declining saber-toothed cats, and a mysterious large cat called Panthera youngi has also been found in China.
Oh, interesting.
What do we know about it?
Panthera youngi is a bit of an enigma. Despite its name, it's more closely related to lions than tigers.
Okay.
Some believe it might even be an ancestor of the cave lion, which became a dominant predator later in the Pleistocene.
A potential lion ancestor in prehistoric China.
Yeah.
Each new discovery seems to add another layer of complexity to the story of the Eurasian steppe.
It really does.
It's like a prehistoric detective novel, piecing together the lives of these creatures from the fossil record.
And just when you think you've got a grasp on this prehistoric world, another twist emerges. Let's shift our focus southward, where a different kind of ecosystem thrives.
Okay, I'm ready for a change of scenery.
Yeah.
What's happening in this southern region?
Unlike the fluctuating conditions of the north, southern China enjoyed a relatively stable climate during the Pleistocene. This gave rise to what's known as the Stegodon Eleuropoda fauna.
Stegodon Eleuropoda fauna.
Yeah.
It sounds intriguing, but what does it actually mean?
It's named after two of its most prominent members, the Stegodon elephant and the giant panda. This fauna represents a unique collection of animals that thrived in this stable environment. And remarkably, many of them, including the giant panda, survive to this day.
Wait, so giant pandas were living alongside elephants. That's not an image I would have conjured up on my own.
Yeah.
Tell me more about these stegodon elephants. I've heard they had a rather unusual feature.
You're probably thinking about their tusks. They were positioned incredibly close together, which meant their trunks had to adapt to fit between them.
Oh, wow.
Imagine having to constantly position your nose to the side.
That's quite the adaptation.
Yeah.
It's amazing how evolution finds a way to make things work. Even when they seem awkward at first glance. The southern fauna is starting to sound like something out of a fantasy novel. Pandas, elephants with sideways trunks. Were there any other fantastical creatures living in this prehistoric paradise?
How about a giant ape that stood nearly 3 meters tall and weighed over half a ton?
Okay, now you're talking a giant ape. This is getting more and more fascinating. Tell me everything you know about this gentle giant.
We're talking about Gigantopithecus, and its discovery is as intriguing as the creature itself. The first Gigantopithecus fossils weren't found in a dig site, but in a Hong Kong apothecary shop.
Seriously?
Exactly.
Like in a shop selling traditional medicine?
Exactly.
Wow.
It highlights how paleontological discoveries can emerge from the most unexpected places. It makes you wonder how many potentially significant fossils have been lost over time.
That's a sobering thought.
Yeah.
But let's get back to this massive ape.
Okay.
Was it like a real-life King Kong rampaging through the jungle?
Despite its imposing size, Gigantopithecus likely moved on all fours like modern gorillas. And while we don't have a complete skeleton, tooth analysis suggests it was probably a herbivore, munching on bamboo and other plants.
So a gentle giant rather than a fearsome monster?
Yeah.
I love how these prehistoric creatures are constantly defying our expectations. But so far, we've been focusing on the creatures themselves. What about the landscape?
Yeah.
Were there any major geological events shaping these ecosystems?
One of the most significant events during the Pleistocene was the dramatic rise of the Tibetan Plateau. It created a high-altitude, cold environment that had a profound effect on animal adaptations and migration patterns.
So this rising plateau was like a giant shakeup for the ecosystem.
Absolutely.
Forcing animals to either adapt or move on.
And one of the most exciting discoveries related to this event is the Coelodonta tibetana, an early woolly rhinoceros found in Tibet.
Wait, an early woolly rhinoceros?
Yes.
In Tibet?
Yes.
This finding challenges traditional theories about where this iconic Ice Age species originated.
Right.
We tend to picture them roaming the frozen north, but it seems their story might have begun in the high altitudes of Tibet.
That's right.
This is incredible.
Yeah.
It completely changes my understanding of woolly rhinos.
Yeah.
Tell me everything you know about them. Those incredible creatures with their thick fur coats and massive horns.
Right.
Truly capture the essence of the Ice Age.
They really do.
I've always been fascinated by their adaptations to the cold, dry grasslands of the north.
Their adaptations were remarkable.
Yeah.
That thick, shaggy coat.
Yeah.
Those massive horns.
Right.
They were perfectly suited to withstand the harshest conditions.
And didn't we even manage to figure out their coat color?
Yeah, we did.
Thanks to some amazingly preserved remains.
Yeah.
What color were they?
They were a rather stylish ginger brown.
Oh, really?
Not only would that have provided excellent camouflage, but it just seems fitting for such a magnificent creature.
Ginger brown.
Yeah.
That's way cooler than I imagined.
It is.
But you know, there's another large rhinoceros I've always been curious about.
Okay.
The Elasmotherium.
Right.
It had a single massive horn and lived around the same time.
Yeah.
Were they related to the woolly rhino? Like a larger, more imposing cousin?
Despite their shared love for open habitats. Right.
And impressive horns.
Yeah.
The Elasmotherium and the woolly rhinoceros weren't closely related at all.
Oh, really?
The Elasmotherium belonged to a separate lineage that died out much earlier.
So 2 different rhinoceros lineages, both with incredible horns, roaming the Eurasian steppe.
Exactly.
It just goes to show how diverse this prehistoric world truly was.
It really does.
And speaking of incredible creatures, we can't forget about the most famous Ice Age icon of them all.
Right.
The woolly mammoth.
The woolly mammoth.
These magnificent creatures have captured our imaginations for centuries.
Yeah.
I've always pictured them as the ultimate symbol of the Ice Age.
Right.
Perfectly adapted to the frozen tundra.
That's the common perception.
Yeah.
But it's not the whole story.
An outlier?
Yeah.
What do you mean?
Well, there's a common misconception that all mammoths were cold adapted.
Okay.
But the truth is, most mammoth species thrived in warmer climates. So the woolly mammoth was the one who decided to brave the frozen north.
That's right.
While its relatives stayed in more comfortable environments.
Exactly.
It's a fascinating twist on the traditional narrative of mammoths.
It is.
I love how these prehistoric creatures constantly challenge our assumptions.
Yeah.
It makes you wonder what other surprises are hidden in the fossil record, waiting to be uncovered.
Absolutely.
And on that note, let's delve deeper into the lives of these incredible creatures.
Okay.
We've got a lot more ground to cover.
Sounds good. The Pleistocene Epoch was a time of tremendous change, with fluctuating climates and shifting landscapes playing a crucial role in shaping the evolution and distribution of life across the Eurasian steppe.
Yeah, it's almost like a giant puzzle, piecing together the clues from the fossil record to understand how these creatures adapted and interacted with their environment.
And sometimes the pieces of the puzzle fit together in unexpected ways.
Right.
Challenging our assumptions and revealing new perspectives on the past.
Speaking of unexpected discoveries, we were just discussing how the woolly mammoth, that iconic symbol of the Ice Age, might have actually been an outlier in the mammoth family, with most of its relatives preferring warmer climates.
That's right. It's a reminder that we shouldn't make generalizations about entire groups of animals based on a single species.
Okay.
The woolly mammoth was adapted to the frigid tundra, but other mammoths thrived in a variety of environments, from forests to grasslands.
It's a testament to the diversity of the mammoth family and their ability to adapt to different ecological niches.
Right.
What were some of the other notable mammoth species that roamed the Eurasian steppe during the Pleistocene?
One of the most widespread was the steppe mammoth, Mammothus trogontheri.
Okay.
These mammoths were larger than their woolly cousins, with straighter tusks and a slightly less shaggy coat, suggesting they were adapted to slightly warmer climates.
So it was like a mammoth family reunion out in the Eurasian steppe, with woolly mammoths mingling with steppe mammoths and other relatives, each adapted to their own particular niche in this vast landscape. What about other differences between these mammoth species? Did they have distinct diets or behaviors?
Absolutely. While all mammoths were herbivores, Their specific diets varied depending on their habitat and the available vegetation.
Right.
Woolly mammoths, for example, grazed primarily on grasses and sedges, while steppe mammoths might have included more trees and shrubs in their diet.
So their diets reflected the vegetation available
in
their respective habitats.
Yeah.
Makes sense.
And their behaviors likely differed as well. Woolly mammoths adapted to the harsh conditions of the tundra, probably lived in smaller, more nomadic herds, while steppe mammoths, inhabiting more temperate regions, might have formed larger, more stable social groups.
It's fascinating to think about how these seemingly subtle differences in diet and behavior could have allowed different mammoth species to coexist in such a vast and varied landscape. It speaks to the incredible power of adaptation and the way in which evolution can shape creatures to fill specific ecological roles.
Exactly. It's a reminder that diversity is key to a thriving ecosystem, with different species contributing to the overall balance and resilience of the natural world.
And of course, we can't forget about the impact of these magnificent creatures on the environment around them. How did mammoths shape the landscape of the Eurasian steppe?
Mammoths, with their massive size and grazing habits, were like ecological engineers shaping the very landscape they inhabited. Their powerful tusks were used to uproot trees and shrubs, creating clearings that allowed sunlight to reach the ground and promote the growth of grasses and other herbaceous plants.
So they were playing a crucial role in maintaining the balance between forests and grasslands.
And their dung, rich in nutrients, fertilized the soil, creating fertile patches that supported a diversity of plant and animal life.
It's almost like they were gardeners of the steppe.
That's a great analogy.
Shaping the vegetation and creating habitats for other creatures.
Their presence had a cascading effect on the ecosystem, influencing everything from plant diversity to the populations of other herbivores and predators.
It's amazing to think about how these seemingly gentle giants played such a crucial role in shaping the prehistoric world. But sadly, as we know, their reign eventually came to an end.
It did.
What factors contributed to the decline and eventual extinction of mammoths?
That's a question that continues to fascinate and puzzle scientists. As with most extinction events, it was likely a combination of factors that sealed their fate. Climate change, with its associated shifts in vegetation and habitat availability, certainly played a role, as the Earth warmed at the end of the Pleistocene. Forests expanded, encroaching on the open grasslands that mammoths relied on for food.
So it was like their world was literally shrinking around them as forests replaced the open grasslands they called home.
And as their habitat dwindled, they would have faced increased competition for resources, making survival even more challenging.
And of course, we can't ignore the impact of humans who were becoming increasingly widespread during this time. Were our early ancestors playing a role in the demise of these magnificent creatures?
That's a debate that has raged for decades. And while we can't say for certain what role humans played, there's no doubt that they were present on the landscape and interacting with mammoths in various ways. There's evidence suggesting that early humans hunted mammoths, utilizing their meat hides and bones for food, clothing, and tools.
So human hunting might have been another pressure point.
It might have been.
For mammoth populations, especially as their habitats were shrinking.
It's a complex issue. And scientists are still trying to disentangle the relative impacts of climate change, human hunting, and other factors. But it's clear that mammoths were facing multiple challenges during this period of environmental upheaval.
It's a reminder that extinction is rarely a simple event. Often driven by a complex interplay of factors.
Exactly. And the story of mammoths serves as a cautionary tale. Highlighting the importance of understanding how environmental change and human activities can impact even the most iconic and seemingly resilient creatures.
Speaking of resilience, we've talked a lot about how creatures adapted to the changing conditions of the Eurasian steppe. But what about the landscape itself? Were there any other major geological events that shaped this vast region.
One of the most dramatic events was the continued rise of the Tibetan Plateau, which we touched on earlier. This uplift, driven by the collision of the Indian and Eurasian tectonic plates, had a profound impact on the environment and the creatures that inhabited it. Imagine this vast plateau rising thousands of meters into the sky, creating a barrier to weather patterns, influencing monsoon cycles, and altering the very flow of rivers.
So this rising plateau was like a giant geological ripple effect, reshaping the landscape and impacting everything from climate to animal migration patterns.
Exactly. And as the plateau rose, it created a mosaic of new habitats, from high-altitude grasslands and alpine meadows to snow-capped peaks and deep valleys. This diversity of environments spurred evolutionary adaptations, leading to the emergence of new species and diversification of existing ones.
It's fascinating to think about how this geological event, millions of years in the making, played such a crucial role in shaping the biodiversity of the region.
Absolutely. And the impact of the rising Tibetan Plateau wasn't limited to the immediate surroundings.
It also influenced weather patterns far beyond its borders, affecting monsoon cycles and contributing to the formation of vast arid regions in Central Asia.
So it's like a domino effect, with this geological uplift triggering a cascade of environmental changes that rippled across the continent.
Precisely. It highlights the interconnectedness of Earth's systems and the profound ways in which geological events can shape the evolution and distribution of life.
Okay, so we've got this dramatic backdrop of the Tibetan Plateau rising, creating new habitats and influencing weather patterns. How did these changes impact the movements of animals across the Eurasian steppe?
Imagine a vast open landscape stretching from the Atlantic Ocean to the Pacific. A mosaic of habitats constantly changing in response to glacial cycles and the rise of mountain ranges. Animals were constantly on the move, following their preferred food sources and seeking suitable climates.
It was a dynamic system, with species expanding their ranges, contracting, and even going extinct as conditions shifted.
It must have been a constant dance of survival.
It was.
With creatures adapting and migrating to keep pace with the changing world.
Were
there any particular patterns or trends in animal movements that stand out?
One of the most notable patterns is the southward movement of many cold-adapted species during glacial periods. As ice sheets expanded across northern Eurasia, animals like the woolly mammoth and woolly rhinoceros extended their ranges southward, seeking refuge in more temperate regions.
So it was like a giant southward migration.
It was.
With creatures from the frozen north pushing into new territories as the ice sheets advanced. I can only imagine the kind of ecological shakeups that must have caused.
It would have been a tumultuous time, with new species interacting, competing for resources, and sometimes even driving each other to extinction. It's a reminder that ecosystems are constantly in flux, responding to both internal and external pressures.
And, of course, we can't forget about the impact of humans on this prehistoric world, where our early ancestors playing a significant role in shaping the fate of these Ice Age creatures.
That's a question that has sparked countless debates among scientists. There's no doubt that humans were present in Eurasia during the Pleistocene, and evidence suggests they were skilled hunters, capable of taking down even the largest megafauna. But the extent to which human hunting contributed to the extinction of these creatures is still a matter of ongoing research.
It's like a giant prehistoric whodunit.
It is.
With scientists trying to piece together the evidence to determine the role of humans in the extinction of these Ice Age giants. What are some of the key pieces of evidence that researchers are examining in this paleontological detective story?
Well, one of the most compelling lines of evidence is the timing of human arrival in certain regions and the subsequent disappearance of megafauna. In many cases, the arrival of humans coincide with a sharp decline in the populations of large mammals, suggesting a potential link.
So it's almost like a pattern repeating itself across the ancient world. Humans arrive and megafauna populations plummet. That's pretty compelling evidence, wouldn't you say?
It's certainly suggestive. But it's important to remember that correlation doesn't always equal causation.
Okay.
Scientists are also looking at other factors like climate change and habitat loss to determine the relative contributions of these different forces to the extinction events of the Pleistocene.
It's like trying to untangle a complex web of interactions with climate humans and other ecological factors all playing a role in shaping the fate of these ancient creatures. It's a reminder that extinction is rarely a simple process. It's often driven by a combination of factors.
Exactly. It's a multifaceted puzzle.
Yeah.
And each new fossil discovery, each scientific breakthrough brings us closer to understanding the intricate tapestry of life that existed during the Pleistocene Epoch.
It's almost like we're time travelers.
Yeah.
Peering through a window into a lost world, trying to make sense of the forces that shaped it and the creatures that called it home.
That's a beautiful way to put it.
Yeah.
And the more we learn about the Pleistocene, the more we realize how interconnected our world is.
Right.
And how the echoes of the past continue to resonate in the present.
We've touched on it briefly, but I think it's time we discuss the Gigantopithecus.
Ah, yes, the Gigantopithecus. A creature shrouded in mystery and, dare I say, a bit of controversy.
Controversy. Yeah. Tell me more. I'm always up for a good paleontological debate.
Well, you see this massive ape standing nearly 3 meters tall and weighing over half a ton. Has sparked countless debates among scientists.
Okay.
It's a bit of a puzzle, really.
Yeah.
We know it existed. We have the fossils to prove it.
Right.
But there's still so much we don't know about its behavior, diet, and ultimately its fate.
Okay, let's break this down.
Yeah.
What do we know for sure about Gigantopithecus?
Right.
I mean, the name itself conjures up images of a colossal King Kong-like creature rampaging through the jungle. Is that accurate picture?
Not quite. While it was undoubtedly an impressive creature, the largest ape to ever walk the earth as far as we know, it was likely more of a gentle giant than a fearsome monster.
Okay.
Fossil evidence suggests it moved on all fours, much like modern gorillas.
Right.
And its teeth indicate a primarily vegetarian diet, with bamboo being a staple food source.
So not quite the terrifying beast that its name might imply.
Well, no.
But still 3 meters tall and over half a ton?
Yeah.
That's an incredible size.
It is.
I can only imagine what it must have been like to encounter one of these creatures in the wild.
It would have been an awe-inspiring sight, to be sure.
Yeah.
And its sheer size has led to some intriguing theories about its role in the ecosystem. Some scientists believe it might have even interacted with early humans, possibly competing for resources or even inspiring ancient myths and legends.
Wow, now that's a thought-provoking idea.
Yeah.
A giant ape sharing the landscape with our early human ancestors. It sounds like something straight out of a fantasy novel.
Right.
But I have to ask, what ultimately happened to Gigantopithecus?
Right.
Why did this massive ape disappear from the face of the earth?
That's the million-dollar question. And unfortunately, we don't have a definitive answer yet.
Okay.
Some theories point to climate change and habitat loss as contributing factors, while others suggest competition with other species, including early humans, might have played a role. It's a reminder that extinction is a complex process, often driven by a combination of factors.
It's almost like a detective story.
It is.
Piecing together clues from the fossil record to unravel the mystery of Gigantopithecus.
That's right.
And it highlights how much we still have to learn about the prehistoric world and the forces that shape it.
Precisely. Each new fossil discovery, each scientific breakthrough brings us closer to understanding the intricate web of life that existed millions of years ago. And who knows what other fascinating creatures and stories are still waiting to be uncovered.
It seems like every layer we peel back reveals another fascinating creature or an unexpected twist in the story of the Eurasian steppe. It's truly an incredible journey through time.
It really is. And it's not just about uncovering the past.
Right.
It's about understanding how the events and adaptations of the Pleistocene Epoch continue to shape our world today.
That's a great point. We often think of the past as something separate from the present. But it's all connected.
Exactly. The echoes of the Pleistocene resonate in our modern ecosystems, in the distribution of species, and even in the challenges we face today, such as climate change and biodiversity loss.
It makes you wonder what the Eurasian steppe would look like today if these incredible creatures had survived? Would we be sharing the landscape with woolly mammoths and giant hyenas?
It's a tantalizing thought experiment.
Right.
How would human societies have developed alongside these magnificent beasts? Would our relationship with nature be different?
It's a reminder that the world we live in is just one possible outcome.
Yeah.
Shaped by countless events and interactions over millions of years.
Absolutely.
I think that's a powerful message for our listeners. The Pleistocene Epoch wasn't just a time of incredible creatures.
Right.
It was a time of tremendous change and adaptation.
Uh-huh.
By studying the past, we can gain valuable insights into the challenges we face today.
Yeah.
And perhaps find inspiration in the resilience of life itself.
Absolutely. The creatures of the Eurasian steppe faced a dynamic world.
Yeah.
And their adaptations, migrations, and extinctions hold valuable lessons for us as we navigate a rapidly changing planet.
This has been an incredible journey through time exploring the fascinating creatures and dynamic landscapes of the Eurasian steppe during the Pleistocene Epoch. It's been a story of adaptation, extinction, and the interconnectedness of life.
And it's a story that continues to unfold as new discoveries shed light on the mysteries of the past and remind us of the profound impact of our choices on the future.
So to our listeners, we leave you with this final thought.
Yeah.
What lessons can we learn from the Pleistocene Epoch? How can we apply these lessons to create a more sustainable future for ourselves and the incredible diversity of life that shares our planet? The answers to these questions might just hold the key to ensuring that the story of life on Earth continues to unfold for millions of years to come.